Now, when you check the routing table, the previous lab which we did, you will see in the routing table some routes having some having OIA, some having E2. As it is written here, the routes that are learned from the same area, the network and the routes from the same area. In another word, type 1 LSA and type 2 LSA will have O. When routes are learned from type 3 LSA, you will always have IA. Type 3 LSA is, you see, summary. Type 1 and type 2, you see, network, router. Now, when we learn routes, we are type 5. Type 5. You will have E2. The default is E2, but you can convert it into E1 if you wish. So what is E1? If you want the pathcast to be calculated for those external networks, outside networks, if you want the pathcast to be added, it's E1. But mostly people don't like it. They don't want the pathcast to be calculated. That's why the default is E2. What do I mean by this? What is the meaning of calculating pathcast, not calculating pathcast? Let me show you the picture. You see this picture. This explains what is E1 and what is E2. The default is E2. And the default will not add the pathcast. Will not. Will not add pathcast. Both are type 5 LSA. But one is going to calculate the pathcast, which is E1, not default. This is default. E2 is default. E1 is not default. E2 is default. And E1, you need to tune if you want, you see. What is the difference between E2 and E1? Assume these are all EIGRP routes coming from Autonomous System 1 to OSPF. This is where the redistribution happens. While redistributing, you are saying for all EIGRP network, this is the cost. You are giving the cost. If you don't give this, for all EIGRP route, the cost will be 20. That is the default one. You don't want the default cost, and you are providing some metric as seed metric.
Okay.
We call it a seed metric. You just give some number like 1785 for those EIGRP learned routes that got redistributed to OSPF as a OSPF cost. You see, between R1 and R3, there is a cost of 10, which is not added. Between router 3 and router 5, there are two links and two different costs. 10 plus 10 is there, but it is not added. Even on R1, you see the same cost which was there while redistributing here. There is no path cost added. Why? Because whether you calculate the cost or not, even if you don't calculate, no problem, no. This is the only exit to go out. Why you want to calculate the cost? Whether you calculate the cost or you don't calculate the cost, you got only one option. Only one ASBR. Mostly only one ASBR people have. If you have multiple ASBR, like R1, if you have another place where you take the roots of EIGRP, the same EIGRP, and redistribute, then you may need to calculate the cost to compare which is the closest to ASBR. But when you don't have multiple exit to the external world, when you have only one, there's no point of calculating the cost. It's of no use. That is why E2 is kept as default. E2 is default. Path cost you don't want to calculate, because whether you calculate or not, that's the only path you have to go. You don't have other paths to compare and see which path is cheaper. So E2 is default always, unless you change to E1, your path cost will not get added. You see here, path cost is added to 1785, 10 plus 10 plus 10, 30 is added. You get this 1815. See? If you wish to calculate the path cost while redistributing, you should say E1 type. Type command. There's a command called metric type. E1. When you don't mention metric type E1 during the redistribution time, it's going to be E2. Path cost will remain same everywhere. Let's see this in the command line. Router 10 is in this corner. EIGRP is in the left. Router 10 is in the right. And router 10 show IP route OSPF. Oh, sorry, there's no route. I think I didn't save some configurations. Show IP OSPF neighbor. No neighbor. OSPF interface.
I think the interface are down.
Interfaces are up, but OSPF is not running. Let me enable OSPF interface loopback 0. Interface range loopback 0, comma Ethernet 0/0 hyphen no hyphen, and IP OSPF 1 area 20. Show IP OSPF interface brief. Okay. Let me go to router 9 and See what has happened. Right. I'm expecting neighbor between 9 and 10 will come. Meanwhile, we'll go to router 8.
Okay.
Interface range loopback 0, Ethernet 0/1. Zero. Okay. So we got neighbor between 8, 9, and also here I can see between 9 and 10. I'll move to router 7. Good, router 7 is already having neighbor. Let's go to router 6. Show IP OSPF interface brief. Okay. While redistributing, we have said just take the EIGRP route, including the subnets, and give. So I told you, when you don't mention a metric value, a cost for the EIGRP network, the default is going to be 20. I'd like to show you that on router 10, all the way down there, router 10. You will see the cost of EIGRP routes will be 20. Show IP route EIGRP. Sorry, OSPF. If you go to E2, you see all the E2 networks are having 20. These two are E2 network. They're having cost of 20. And even these two are E2 network, 20. Now, I go to router 3 and I say router OSPF 1 redistribute subnet, and I'm going to say simply metric, not metric type. This is simply metric, and I'm going to say 100. So I'm saying no 20. I don't like the 20, which is default. I want OSPF to consider metric 100 for all the EIGRP networks. Means type 5 should have metric of 100. Now I'm giving metric 100 on router 3. But when I check in router 10, there is no increase in the metric, even though there are many links in the middle and many routers in the middle. Those path costs will not be seen added. I'll show you. Look at this. The 100 that I gave is the same. There is no change. There is no path cost added because it is E2 by default. But when I go and say metric type E1, now there will be change in the metric. This 100 will not be 100 now. Why? Because between router 3 and router 10, there's at least 1, 2, 3, 4, 5, 6, 7 links are there. If each link is cost 1, then I should see 107. Okay, it's 170, which means each link is 10. 10 plus 10 plus 10 plus 10 plus 10 plus 10. 170. You see? Now, if I go to router 6 and check the cost, what should be the cost? 100, 10, 20, 30. 130. Let's go and check in R6. R6. Should I be route? Yeah, it's 120. Each link is 10 cost. And the seed metric is 100. So you got total 130. This is clear? E2, E1.
Yes, sir.
Yeah. So if you simply say metric, then you are giving seed metric. If you say metric type, you are trying to change from E2 to E1. All right. Now, do you see my screen? Do you see the presentation that I'm showing?
Yes,
Okay.
I can see it.
Okay. So right now you are not seeing through the classroom which we usually attend. This is through the desktop screen share through Google Desktop. Just take it. It's okay. You don't need to go there. You can also remotely log in if you want later. Now, I don't see these things in use in the real world. If you want to reduce the LSAs that are flooded, you can set the limit. You can say if maximum LSAs are these many numbers, then what is the action? Just give a warning saying too many advertisements are coming, or how long I should ignore. So, see, this is a very optional one. In case if there is an excessive LSA generated by other routers, can drain local routers resource because too many advertisement, too much of CPU because of new changes, the new LSAs are coming. And if your processor is keep on processing the LSAs that are coming every now and then there won't be place for the other traffics to get processed. So you may wish to limit the advertisements, but that's not a good idea. Advertisements are helping your network to be converged to the latest changes. See, those days we had very limited resource. Those days, this is an important feature, maybe, but not now. Now we have enough of CPU. We have modular CPUs. For OSPF, there will be separate resource allocation, and for BGP, there will be another separate resource allocated, so they don't interact. All right, so no need to worry about these commands. Ls. All right, this is another important topic in OSPF. Like LSA types, this is also important. OSPF
Okay.
does auto cost, meaning we saw here that the cost for each link is 10. Who decided that? I did not mention anywhere cost. Neither you mentioned cost. but you see a cost for each link that is automatically calculated based on the bandwidth. Based on the bandwidth, it is calculated automatically. For example, if the bandwidth between R1, R2 is Ethernet. What is the Ethernet's bandwidth? 100. No, 10 meg. Fast Ethernet is 100. Ethernet is only 10 meg. Gig Ethernet is 1000 meg. So auto cost is calculated like this. The reference bandwidth divided by the actual bandwidth, because we have E, I'm writing 10 here. Which is going to give me 10 as the cost. That's why we had 10. We saw 10 there. This is okay if you are using Ethernet and fast Ethernet. But if you are using gig Ethernet, then this auto cost calculation is not okay. Why? Let's assume I got another router, R4, with gig Ethernet, and R5 with fast Ethernet. Now, what will be the cost via R5? Fast Ethernet is 100. So cost is equal to?
This will be
Exactly.
One.
1 and 1. Now, what will be the cost via R4? There is no fraction number allowed. So that is also going to be 1.
Right. Okay.
That's also going to be 1. This is a problem. Why? OSPF is not clever enough to decide this is the best path. It thinks both are equal. But this is fast Ethernet, just 100 meg. With gig Ethernet, 10 times more than 100, 10 times more than fast Ethernet. But according to OSPF now, it is going to do equal cost load balancing because it could not differentiate if the cost goes more than 100. If the cost is more than the reference bandwidth, this is the reference bandwidth on the top. If the cost is more than the reference bandwidth, then this algorithm cannot, this formula cannot do the right justification. So, what we should do? We should change the reference bandwidth by using this command. The default is 100 on the top. If you change that to 1000, then this cost will be 10. This will be 100. And this will be 1. Isn't it? 1000 divided by 100 is 10. Which one? The fast Ethernet. So you got 10 as the cost. 1000 divided by 1000 is 1. So to change this numerator value, you need this formula. And if you're changing, you should change it in every router. You got it? Okay.
Yes.
So this is about auto cost. But if you want to calculate, so if you do not want to calculate using the formula, if you wish to provide the cost manually, use this. Go directly to the interface and say what cost you want to mention. Right, so if you will have both, which will override which, the manual cost that you give on the interface overrides the calculated cost. So what do we see here? We can leave it default calculated cost, or you can also go and specify a cost that you want. When you specify, that gets more preference. Auto cost reference bandwidth is 100 by default, but if you're working on a gig Ethernet environment, don't forget to change the reference bandwidth at least to 1000. And if you're using 10 gig interfaces, then you need to increase to 10,000. Is this clear?
Yes, sir.
Okay.
Yes, sir.
Later, what you can do is you can do a lab on GNS3, one link with fast Ethernet, another link with Ethernet, and you can do this auto cost reference bandwidth. You might have seen this in my channel videos. When I do with EVE, I get options to. So I get only one option. I can use only Ethernet. But when I use GNS3, I can use serial, I can use fast Ethernet, I can use Ethernet. It depends again on iOS in EVE. So that's it. It's easy. If you want to change the numerator value from 100 to 1000 so that SPF can differentiate Ethernet, gig Ethernet, fast Ethernet, you can do so. You can also give cost manually on every link in the path. That will get more precedence than the auto cost. So this chapter was a very important chapter, talking more about LSA types, virtual link, and then the route types. Intra area will have O, inter area will have OIA, external will have E2 or E1, and we saw E2 is the default, and in E2 no path is calculated, no path cost is added. In E1 it gets added. And we also saw that you can limit the LSA types, which is not really a recommended one. Alerts, signals, those things are very important for you to get converged to the topology. It's not good to limit. If you want to change the cost, you can go directly to the interface and give a cost, or if you wish to do changes to the algorithm so that the auto cost reference bandwidth can be different than 100. 100 is default. But when we have gig Ethernets, we need more than 100. So you can go and change it by using auto cost reference bandwidth command, where under router OSPF. Now,
Go back on mute.
Summarization is good. Why? You see, in the previous chapter, in order to reduce the LSAs, in the previous chapter, in order to reduce the LSAs, they were putting some filters, which is not good. Means LSA threshold values. Not good. You're avoiding important updates by setting threshold. Instead, you can reduce the advertisements, LSAs, by proper summarization. Summarization reduces the LSAs that are going to be flooded. When I say flood, you should not misunderstand like broadcast. They are multicast. They are sent to every OSPF router. So those flooding can be less in number if you do proper summarization. When we get many networks from many subnets from same network, we can summarize so that there will be very less number of advertisements. Now, where to summarize? EAGRP allows you to summarize anywhere you want. You can go to one of the router somewhere in the corner or in the middle. You can do manual summarization under the interface. OSPF don't do like that. EAGRP does that. EAGRP allows you to do summarization anywhere you want. But OSPF is very clear and very neat in providing summarization option. You can only do summarization on the borders. That's very good. That's the right place to do summarization. Borders. Between two area. You have ABR. That's the best place. Between two autonomous system, you have ASBR. That is the best place. So you have support for both ABR summarization and ASBR summarization. ABR summarization is between two areas, a non-backbone area and a backbone area. That is ABR summarization. ASBR summarization is on the ASBR where we did redistribution. Even though both are OSPF summarization, the commands are not going to be same. Why? For ABR summarization, there are two areas involved, non-backbone area and the backbone area. But when you take ASBR, the routes are not coming from the same autonomous system, OSPF. It is coming from another autonomous system. That may be EIGRP. EIGRP have got no idea about areas. So the command when we use for summarization in ABR and in ASBR are not same. There will be something mentioned about area like area 10 range in ABR summarization. In ASBR summarization, you will have summary address command. There is no area mentioned in that command. Let us see that in the presentation first, and then we'll go and do the lab. You see here, this page explains why we should do summarization. First point, minimize the number of routing table entries. Of course, yes. When I do summarization on the border, the type 3 LSAs are going to be less. As a result, the routes in the routing table will also go less. And the routes given to other area will also be less. So definitely this minimizes the size of the routing table. Nextly, localize the impact of topology change, meaning what? If there is any link failure in an area, the failure will impact only the members of that area. It won't go to other area. Localize the impact of topology change. Why it won't go to other area? Because we have done summarization. For example, you have 10.1.0.0/16, 10.2.0.0/16, 10.3. At this you have summarized 8. You have summarized like this on this router. So when 10.3 goes down, will there be any update sent? No. No update sent. Now you may say, if no updates are sent, then how area 2 routers will know about this failure? They need not to know. There is no need for them to know because they are not frequent talker. That's why you have put them in different area. They are not frequent talkers. That's the reason we have put them in different areas. So that's not so important for them. It's not so important for them to know about the small changes. So localize the impact of topology change. That happens only when you do proper summarization. I was talking about two types of summarization, ABR and ASBR. The ABR summarization reduces the type 3 LSA. This is ABR summarization. And reduces type 5 LSA if you do summarization on ASBR. In this picture, we don't have ASBR. Type 5 LSAs and type 3 LSAs can be reduced. Can you do summarization for type 1 and type 2? No. Type 1 and type 2, local LSAs, we don't do summarization. Only type 3, between areas, and type 5, between autonomous system. Now here, how do you do summarization? What subnet mask I should use if I want to summarize between 8 to next 8 numbers? 8, 9, 10, 11, 12, 13. So you want to summarize this. And then you want to separately summarize this 5. Very simple. 8 is a block size actually. All right, after 7 is 8. So you see when you have 1, 2, 4, 8. So I can say starting from 8, 255 minus this one, 7, 248. So that starting from 8, the next 8, which is up to 15, gets summarized like this. Yeah. So which will be what? Slash 21. Slash 21. You know how we got 21? Because this 3-bit. You are in mute. Now this one, starting from 16 to 19, you want to summarize. So you need only these 2 bits. 255 minus 3. 2 plus 1 is 3, no? So you get 252. 255 minus 252. So 16, and then the next 3 will get summarized. So this will be slash 22. Now this subnet mask, if you don't use it correctly, then it will be difficult for you to see the summary. Or you do one thing, you can simply summarize all of them together by putting 0, 0. If you have confusion in summarization, you can simply do like this. You don't need even this one. You can put 0 here. But what you saw here in this presentation is more accurate summarization. You want to do summarization only for this to this, 8 to 16, and 16 to 9.
Okay.
This is more accurate. And what if I don't want to summarize for this? Then I should know this. It's easy. You just count after 8 up to 15 you want to. So keep counting, include 8 also. 8, 9, 8, 9, 10, 11, 12, 13, 14, 15. So there's 8 networks I need to shrink. In the binary bit, here is 8, here is 4, here is 2, here is 1. If you want to summarize 8 networks, then you need to make this 0. 255 minus 7 plus 2 plus 1. Sorry, 4 plus 2 plus 1, which is 7. 255 minus 7 is 248. 255 minus 7 is 248. In the third octet only you want this summarization, so you do only on the third octet. It's easy. When you do 2-3 times, you will understand. I was telling you there are 2 types of summarization in OSPF. And this is ABR summarization. You go under OSPF and say area. Which area
Okay.
network you want to summarize? In our case, let's say this is area 1. Area 1. You are doing summarization in ABR. So I need to say area 1 range command 172.16.8.0 255.255.248.0. So it is area 1 range because you got area.
Right.
And this is the area from where the network will come. I want to summarize. So that's the area 1 range. Now you also have ASBR summarization where there is no area. Okay, there is no area, so you simply use summary address command. All right, like this. You want to summarize between 32 to 63. Yeah, so you put 32. Between 32 to 63, how many numbers are there? 31 numbers are there. So 1, 2, 3, 1, 2, 4, 8, 16, 32. So you need to reduce this many. So 255 minus 31. 255 minus 31 is 4, 2, 2. That's what you put here. How 31? Sorry, not from here. Let me, before I put the rounder in the wrong place. 1, 2, 4, 8, 16, 32. So if I add all this, I'll get 31. So this is what I need to subtract, because after 32, another 31 is what going to give me 63. 250 minus 31 is 224. 250 minus 31 is 224. Alright, see, the command is this summary address, and these networks starting from 31, summaries like this. So there is no area involved, so you cannot mention any area number for this. Is this clear?
Yes, sir.
OSPF can also provide a default route. You remember in EAGRP you did default network command, which was advertising the default route to every router in EAGRP. Likewise, OSPF can also advertise the default route to every router in OSPF domain. But if you wish to have a default route, you need to have a default route configured, static default route configured, pointing towards an address, so that you can go to router 1 and say default information originate. When you say default information originate, it takes the default route and advertises. But what if I don't have a default route and I want to have OSPF to advertise it? Then you need to use the keyword always. Default information always command will make R1 to advertise the default route even when there is no static default route available. See, these things we are going to do in the lab, this one and this one. The summarization, default route, we are going to do in the lab. So see this, like always command. Always command allows default route to be advertised even when the default route doesn't exist. Now cost. When we have multiple ASBR, you see R1 is one ASBR, R2 is another ASBR, and both are advertising default route. And you want to prefer R1, so you give low cost. When you say default information originate, you can also mention metric along with that, so that every router here will go this way, and if this router fails, it will switch to this way. So internet service provider A is preferred, primary. This is backup. So what we learn here is you can also use metric keyword along with the default information originate. Right. So this chapter was a small but very informative. Like we learned about why summarization and types of summarization. ABR summarization and ASBR summarization. ABR summarization is the one which we do on the ABR, where type 3 is going to be reduced. ASBR summarization we do on ASBR itself, where type 5 is getting reduced. And we also saw that you can advertise default route using OSPF. For that, you need to have a default static route. If you don't have, you need to use the keyword always. And what other things that we saw here? Okay, the summarization, subnet mask, how to use the subnet mask to match exactly what you want to summarize. Right, lab on this we'll continue in our next class.